Let us continue to example number 2. Still, we're going to draw the shear and moment diagram. All we have to do and remember that we're going to solve for the reactions first. And as you observe now, the uniform distribution is distributed from point B until point C. So again, the naming of letters of this diagram here, or with this beam, is based on the changing, or if there are changing of loads along the longitudinal section of the beam. So like on the leftmost part, it's known as B. Then on the beginning of the distribution, it's in the leftmost part it's A, and at the beginning of the distribution is B, and at the end of the distribution, which is at the end, rightmost end, is C. Okay, so at point A there is a roller. So let's solve for, or no, let's provide a reaction here. This is A vertical, and at point C I will just only place C vertical. Anyway, horizontal has nothing to do with shear moment diagram. Okay, let us now solve for the reactions, but before that, let us resolve the distribution, and the value here is 60 times 3, and this is 180. Alright, so let's solve for AV, and we will be having summation of moment at point C equal to 0, clockwise positive, counterclockwise negative. So you have AV, moment arm, rotate at point C, it's 5 meters, then minus 180. The moment arm is 1/2 of 3 because the distribution is 30. What happened to this one? 1/2 of 30 equal to 0. So therefore our AV, so 180 times 1.5 divided by 5, the answer is 54 kilonewtons. These are AV, and in getting CV, summation of forces, vertical. So upward positive, downward negative. Okay, so you have AV plus CV minus 180 equal to 0. And then our AV is 54, then plus CV minus 180 equal to 0. So solving for CV, it is 180 minus 54, 126. And this is our CV. So these are the values of our reactions. Okay, so what will happen next is we will cut the beam. So from AB to C, there will be 2 segments. So we will be cutting A, and consider the left. Okay, so segment AB, and it includes here the AV, and the distance is X at the point of cutting. And do not forget that you have shear and moment. So let us now formulate the equation. So for the shear equation, it is V equal to the summation of forces. Forces vertical, upward positive, downward negative. So in this case, V is equal to positive AV, and V is positive 54. Next, for segment moment equation is summation of moment clockwise positive, counterclockwise negative at the point of cutting. So moment is now equal to rotation of AV is clockwise and the moment arm is x. So moment equation now is 54x. Alright, so that's for AB. How about for BC? So all we have to do is we're going to cut this one here and consider the left segment. Okay, so buhaton na to. Let's redraw. So this is for BC. And then do not forget na kay A vertical and this is point A. Then you have pila ka meters from A to B. It's 2 meters. So I'll write the 2 meters here. And this is my point B here, point B. So point B starts or marks the beginning of our distribution. Okay, so gi-represent na ko in that manner para makaingon ko nga that is not exactly at until point C, but rather a distance x. Okay, so distance x, and that is from this point of cutting. That's distance x. And do not forget distribution. So the unit here, pila to siya, ang intensity, this is 60 kilonewtons per meter. Alright, so as you observe, naantay shear and moment, but dili na nato kopyahon ang 60 times 3 equal to 180. Tungod kay ang ato ang length of distribution is no longer 3 but rather x. So all we have to do now is get the intensity. So it's going to be the product of 60 and x. That's the resultant. Okay, so pwede na tayo makahimo sa equation. So for shear equation, it's going to be summation of forces vertical, upward positive, downward negative. And then in the equation, you have AV upward, and then what else? This one, 60 times x, and that's downward, so that's negative 60 times x. No? So therefore, shear V is equal to 54 minus 60x. This is our shear equation. Next, for our moment equation. Our moment equation M is equal to the summation of moment at the point of cutting, clockwise positive, counterclockwise negative. So let's start with AV. AV will rotate about this point of cutting here with a clockwise direction. So that's AV times the moment arm from A hunted sa point of cutting. The distance is 2 plus x, or x plus 2. And then next, we have the next one here. So it's counterclockwise. So negative 60x. But what is the moment arm here? Pila may moment arm ana. So it's basically 1/2 of x, no? Okay, that is a rectangular distribution. So 1/2 of x. And moment equation now is AV is 54, x plus 2, then minus 60 times x, so it's 60x squared, yeah, divided by 2. So this is now 30x squared. So we're through with the shear and moment equation. So buhatan na to. Next is getting the shear values. So let's start with segment AB. For segment AB, ato lang i-write balik. The equation is 54. So therefore, our VA and B is 54 kilonewtons. So that's VA equal to 54 and VB equal to 54. So that's how we understand it that way. Next, for segment BC, the equation is 54 minus 60x. So 54 minus 60x. Okay, so ang buhaton na to, since ingon ani naman ang atong equation na naman siya x, then we have to separate at point B. X is 0. Okay, again, we are at segment BC, and then ang atong x is defined from point B. And since we are citing point B, or since we are at point B, then therefore it coincides with a function of x equal to 0. So here, so bx is equal to 0. So our shear B is 54 minus 60 times 0 as the value sa x. VB is positive 54 kilonewtons. And as you can see, this value here, this one is just equal to this value, VB. Different segments, but same point, therefore they should be having the same value. Okay, but not all the time because there na may mga situations nga dili nato siya pwede ma-apply in that manner. So that's on the next procedure. So in this case, we are still shear and moment equation pa man napata diha. Let's proceed with at point. Let's use this one at point C. X is the distance between B to C. Mao na atong buhaton. So the distance between B to C is 3 meters. So therefore this is 30. So karon, we can now use VC, the same equation, 54 minus 60 times 30. VC is 54 minus 60 times 30. It's negative 126 kilonewtons. Right. So, nanatay values for shear. Ang buhatan nato next is to draw the beam again. So, ato i-draw ang beam diri lang nga portion. And then, do not forget na atay a vertical, and then naasa diri C vertical. Then I'll just write this is A, and this is B, and this is C. Yeah, from A to B, this is 2 meters, and B to C, this is another distance 3 meters. And the load So mo na ito ang load. Okay. Right, so ang buhatan next is to drop down a line. And here. And also and I'll place the 0 shear line. So this is 0 shear line. Pasabot ana, babaw sa horizontal, it's positive. Yeah, ubos sa horizontal kay negative. So let's plot the shear diagram. So at point A, the value is 54. Point A. The value is 54 at point A. And then at point B, the value is 54. So, nawa man siya. So actually, ma-relate ra gyud nato nga dapat kani siya diri kay 0 ang slope. Nganong 0 ang slope? Tungod kay ang atong equation kay wala siya pair nga x. So arbitrary siya. So dili siya constant lang siya, wala siya variable. So 54. And then proceed with point B. Segment BC, point B, it's still 54. So na-plot na sad na ako dere. This one. So that's 54. And then at point C, it's negative 126. So negative 126. So I'll place here, this is point C. And let's just say this is negative 126. Okay. How do we connect this 126 and 54? Unsa nato siya pag-connect? Dali ra na nato siya makitaan. Our equation says that it's 54 minus 60x raised to the power 1, meaning we're gonna connect the 54 and 126 with first degree line. Okay, so that's our shear equation or shear diagram. Pero as you observe, whenever gali mo yun ani ang atong diagram, mo intersect gani siya sa 0, ang but pasabot ana kay we have to get the distance here, the distance nga x. So what is that distance x? Asam di siya na belong nga segment? It belongs to segment BC sa shear equation. So we're gonna use this shear equation sa BC in determining the x. No? So ang buhaton ana kay segment BC, it says that it's V equal to 54 minus 60x. So we're gonna use this one. Ningon siya that V daw is equal to 0. So kana siya, that's equal to 0. So therefore, i-transpose din nato siya sa pika side kani or either. So mahimo siyang negative 54 equal to negative 60x. So therefore, ang x nga value ana nga detach siya sa shear equal to 0, that's 54 divided by 60. And the value is 0.9. So that's the x distance. So that's how we plot shear. Next, let us continue in getting the moment values. So for moment values, let's start with AB. Our equation is 54 times x. So that is our equation. So at point A, again, at point A, x is 0. Kaya na nasa tanibalik sa segment AB. No, ato lang na siyang i-refresh diri. Nag-start ang atong x dira. So therefore, x equal to 0 diri, then x equal to 2 meters diha. So MA is equal to 0. Next, at point B, x is equal to 2 meters. So this is MB, and that's 54 times x nga 2. So MB is 108 kilonewtons meter. That's our moment B. Next, let's proceed to segment BC. So our equation for BC is this one: 54 times x plus 2 minus 30x squared. So moment equation is 54 times x plus 2 and then minus 30x squared. Okay, so we are at point B. So therefore x is equal to 0 again. So same rigid na ana. And then ato i-substitute. MB is 54 times 0 plus 2, then minus 30 times 2 square. Ano, not 2, but 0. 0 square. So MB is 54 times 2. That's 108. So again, the value for MB for segment BC is 108, and the other segment containing point B is also 108. That's how to verify whether our answer is correct or not. And then let's proceed with point C. And that's x equal to the distance from B to C. Again, that's 3. Or kung makinamdum ka, you're using the same here in shear. No? Sa shear na siya. Kana. So, the same ra na sila diri ang pag-consider. Then, let's have MC. That's 54 times 3 plus 2 minus 30 times 30 square. So MC is 54 times 5 minus 30 times 9. So MC is 0. But wait, napamoy nakalimtan. Remember this one? It belongs to segment BC. That it says that there is a value x equal to 0.9. So at moment x, or let's call this one as moment O. Okay, point of inflection man tawag na to ana. At point O, x is 0.9. So MO is 54 times 0.9 plus 2 minus 30 times 0.9 square. So MO is 54 times 2.9 minus 30 times 0.9 square. The value is 132.3. This is kilonewtons meter. So, mo ni siya ang reason nga nung gikuha ni nato, because at point O, or whenever the shear intersects at 0, then it means to say that it corresponds to a particular point in moment nga mo give og maximum value. So as you can see, among the values sa imong moment, MA is 0, MB is 108, and MC is 0, then MO is the greatest value among the moment values. So that's really important to get that value. Okay, so what we're gonna do is continue this one here, plotting. So ato lang ni siyang i-continue. And also here. Nahiwi man. Okay. And then also do not forget na akay i-drop down nga point at point inflection. Okay, so ang buhatan nato kay madraw na sa taog 0 moment line. So this is 0 moment line, then positive babaw sa horizontal. Okay, starting with MA. MA is 0, that's point A. So again, this is point A, this is point B, this is point C, and this is point D. Okay, and MA is 0, then MB is 108, so that's 108. And then MC is 0. Ay, nasave di ko sa letters. Di din siya MC diha. This is point O and this is point C. Kana. Okay, so balik ta. MA is 0, then MB is 108, then MC is 0, and then MO is 132.3. So dire lang ako ibutang 132.3. Right, so how do we connect point A kani and point B? So let's go to its equation. So this is the equation, and it is x to the power 1. So it's a first degree line. Okay, first degree to the power 1 man. Next, you have connecting 108 and 132. So atong tan-aw sa equation, this is BC. So in this expression, ang pinaka highest or ang highest nga form sa ato ang exponent is square. So it's quadratic, meaning it's a curve. So we're going to plot it as if we're plotting a curve. And this is second degree. And for the third one, from this 132 and point O or point D or C, so mo gihapon nga segment the same 30x squared, so it's a second degree line. So all you have to do is make a curve. And this is at second degree. There. This is our shear and moment diagram.